We're going to look at exponential functions, which are functions of the form y is equal to a to the x, where a is a number. Up here we have two examples of this. We have y is equal to 2 to the x, and we have y is equal to 3 to the x. We're going to complete the table of values. Consider first 2 to the minus 3. We know this is 1 over 2 cubed, which is an eighth, or 0.125. Two to the minus 2 is 1 over 2 squared, or a quarter, 0.25. Two to the minus 1 is a half, which is 0.5 as a decimal. 2 to the 0, we should know, is 1. We then have 2 to the power 1, which is of course 2. 2 squared, which is 4. And 2 cubed, which is 8. Note how each time x goes up by 1, the values double. If we now look at 3 to the x, 3 to the minus 3 is 1 over 27, and I'll write this as a fraction since it's much simpler than the decimal. 3 to the minus 2 is a ninth. 3 to the minus 1 is 1/3. 3 to the 0 is of course 1. We should know that a to the 0 is 1. So all of these exponential functions will have the value 1 when x is 0. Continuing, 3 to the power 1 is 3, 3 to the power 2 is 9, and 3 cubed is 27. Note each time x increases by 1, we go up by a factor of 3 in the 3 to the x values. Note that for negative values of x, the 3 to the x values are less than the 2 to the x values. For example, we know that 1/3 is less than a half. If we go to the right for positive values of x, the 3 to the x values are higher than the 2 to the x values. Since we know that when x is 0, they're both 1, it's clear that these two graphs must cross at the point 0, 1. Here we have the two graphs. The blue one is y equals 3 to the x, and the red one, y equals 2 to the x. Note how they do cross the y-axis at 1, so the curves cross at this point. To the right of the y-axis, 3 to the x is above 2 to the x, and although less clear, we should see to the left of the axis that the blue is below the red. Note the shape of these curves. The curves get closer and closer and closer to the x-axis over here, but will never get there. The negative x-axis is what's known as an asymptote. It is a line that the curves get closer and closer and closer to, but they never get there. As an example, consider 2 to the minus 1000, which is 1 over 2 to the power 1000. This is an incredibly small number, but it isn't 0, so the curves can never reach the axis. Also, provided a is a positive number, a to the x can never be negative. So all of the a to the x curves exist only above the x-axis.